Fellow algebra students out there, Mr. Irvis here. I'm just picking up after Mr. Mack. He did Unit 1. I'm going to start with Unit 2. Before I do, I'm just going to quickly remind you that by now you should have submitted your homework for Unit 1 review. This is how it should be. You should have the multiple choice written at the top of the page. You should have number 8, number 9, and number 10 worked out. And at the end, just take a pic and upload it to Google Classroom, and then that counts as your homework being done. So we're going to proceed that way for the next several weeks. So make sure that you're checking on Google Classroom every day and making sure you're staying current. Now, it looks like these first couple I have already started. And just to cut down on my time that I have to talk here, this is just straight solving, so I'm reversing all my PEMDAS moves here. So subtract 5, 7 take away 5 is 2, reverse the division by 3, multiply on 3 on both sides, we get 6, and reverse minus 8, and you end up with x is 14, so choice number 4, that's where we're going to go there. All right, our second one, I believe that I did as well. And we're talking about Sophia, who decided to rearrange an equation, and it looks like you could see my markings. The only thing I noticed different here than here is the 7 and the 2x seem to be in different locations. And that means if you're switching locations, we're just talking about commutative or commute. So that is choice number 1, and we're done with those two. Number 3 is basically asking us in which order are things being done to the x. Well, if something is being done in mathematics, you have to follow PEMDAS, which means any parentheses would have to be done. There are none. No exponents there. There are no multiplications near the x. There is a division. They're dividing by 5. So dividing by 5, and then a subtraction, we have an addition, and so subtraction would have to happen last. So we're looking for dividing by 5 and subtract 3. And 3 was subtracted from the result. That looks like choice number 3. And then we just move it on. All right. Then we get down to an equation, and I did rewrite that one, so that save a little bit of time there. And distributive property is always okay. So 5 times x is 5x. 5 times 2, that's really a negative, so make sure you have a negative 10 there. And then we have this minus 6 equals 24. So after you do distributive property, just check for like terms on the same side. So these are like terms. So you can just combine them. That's negative 16 total. So 5x minus 16 equals 24. And you're still trying to isolate this x. So I'm going to add 16 here. I'm going to add 16 there. And then we'll just be left with 5x on the left equaling a total of 40. And just go ahead and undo this multiplication bond with a division. And you can just say x is 8. And there we are. Number 4. There is no line for this one, so we will just make one. There we go. And at the bottom of the page, last question. What is the solution to the following equation? Show it work, blah, blah, blah. So, same thing. I noticed there's distributive properties. I'm going to do that times that, and I'm going to write it over here. I'm going to end up with 3x plus 6. Still, just copying minus 2x. Copy your equal sign. That's distributive property again. So we got negative 2x. Watch this. Negative 2 times a negative 3 is a positive 6. And then you just copy that 3x over. So same rule. So you're looking for like terms. So this and this could combine to make a total of 1x. You don't need the 1, but you could put it. Plus 6. Again, like terms. Boom, boom. All right. Negative 2x and 3 is a positive 1x again. And then you have this 6. So it's like a curious outcome here. I mean, even if you try to get your x's onto one side, you end up doing minus x, which just leaves us with 6 equals to 6, which is always true. Now, we didn't really talk about this very much this year, so don't put too much thought into this. 6 equals 6, since this is always true, that means any value of x you want to put in here is going to make this true. This is an equation that's always true, so that we have to say an infinite number of solutions. That's not something you guys should stress about for the Regents exam because it hasn't really been tested very much. I don't think at all. All right, so let's turn this page over, and we are through the multiple choice. All right, now I did some pre-writing up on the top. You could see PEMDAS is very important here, and if you're solving an equation, you're going to be working reverse PEMDAS because you would like to undo all the things that have been done to this x. So when they say list the operations that have been done to x, and then over here we're going to undo them. All right, so if we're working in reverse, you'll notice that there's a subtraction happen right here. So that looks like somebody subtracted I'm sorry. We're supposed to be listing how they happen to x, not reverse. We'll reverse them later. All right, so it looks like things that happen to this x, it looks like we are 1 multiply by 2. Okay, so after you take the x multiplied by 2, looks like they subtracted 1. All right, the third thing that's happening, it looks like we have a 5 which is being multiplied okay, then you could see that that entire unit there is now being divided by 3. Okay, and then after all of that stuff was done, somebody subtracts 4, and then the answer is 11. Okay, so the usefulness of this is that we can just go backwards, as I mentioned earlier, and we can undo all those things and figure out what x is. So that's what's going on over here. So the first thing we're going to reverse is subtraction of 4. Well, the reverse of subtraction of 4 is add 4. So I'm getting 15, and then I have just a copy, no work here, just rewrite it. Okay, did it. Reversing a division by 3. Well, the reverse of division is multiply. Multiply on this side, of course, on that side. 3's cancel. We're left with 5 times 2x minus 1 equals 45. Okay, that move did it. Multiply by 5. Well, reversing multiply, you're going to divide by 5. So all we have is 2x subtract 1. This division gives us 9. So I reverse that. Done. We need now reverse subtract 1. So I'm going to reverse plus 1. We're dealing with 10 over here equals 2x. And last move, let me just mark this off. Last move, reverse and multiply by 2. Well, let's divide by 2. X equals 5. Okay, that's one sure way to solve an equation. is to reverse PEMDAS. Let me put an L in there, it's probably driving some people crazy. All right, so let's see what we got down here in exercise 7. All right, so these are just straight up solve. So we're going to do all the reverse moves. So I'm going with subtract 2, subtract 2. Copy -3/5 x equals 5. There's several different ways you can proceed here. Some kids like to multiply by 5 so that this is no longer a fraction. So you reverse the division, and you'll have -3x equals 25. And then last move, divide by -3. And you end up with x equals -25/3, and I'd just as soon keep it that way. If you put in your calculator, it is going to be a repeating decimal. It's not worth it. So let it be. Move over to this side. Here's your equal sign, so that means there's several distributive properties going on the left of it, and just one here. So it's kind of a mess. That's all right. 7x minus 14, keep distributing, -3x. Watch this, -3 times 3 is -9 or -9. 5 times x, 5x minus 15. Just copy that plus x. And then you're looking for like terms. This could go together with this. A -14 could go together with -9. So as far as x's go, I'm dealing with 4x. As far as numbers, I'm dealing with -23. All right, and then I have over on this side, I have a 5x and a 1x for a total of 6x and a -15. And if you got x's on two different sides, I'd like you to get them all to one side. I'm going to choose to move the smaller. That will guarantee me at least I don't have to deal with extra negatives. 6x take away 4x is 2x minus 15. You're going to add that 15 to both sides so that you can isolate the x. So 2x, copy your equal sign, be very careful here. -8. Reverse that, dividing by dividing by 2. So we're dealing x equals and -4. All right, that's a lot of work. And if you want to know if you're right, you can always put that -4 back in where x is each time, and you should get a statement that the left side is equal to the right side. All right, last couple of questions. Let's finish up. All right, so here's x in here. All right, I am going to start reversing things. Notice this is a giant division line divided by 6, so I'm going to reverse division by 6. Both sides multiply by 6. 5 times x plus 1, and we have a plus 4 here, and 6 times 4 is 24. Now, if you want to do distributive property here, there's nothing wrong with it. You don't have to, but I know a lot of kids enjoy distributive property, and why wouldn't you? And copy everything else down. After distributive property, look for like terms on the same side. You got 5 and 4, which is 9. So we're dealing with 5x plus 9 equals 24. Let's keep isolating that x. Reverse the plus 9 with a minus 9. 5x equaling, what are we dealing with here? 15. Divide by 5. X is 3. All right, again, you can check your work by plugging that in, see if it's true. All right, last question. Same thing, I got distributive property over here. So that's going to be 5x minus 15, copy the plus 2x. Over here, I got 4x plus 12. I just got plus 3x over here. Like terms, 5x and 2x adds to 7x, copy the minus 15. 4x and 3x adds to 7x, copy the plus 12. Again, this is a curious question here. What's going to happen is you subtract this 7x from here and subtract the 7x from here. And what happens? You end up with an absurd conclusion that negative 15 equals 12. Now again, this, like I said, is an absurd conclusion, which means that this is never going to be true. We all know that 15 is not equal to 12, so that means in this case there are no solutions for x. So some people will write the empty set, which is like a set with nothing in it, which means there's nothing that makes it true. Other kids will like this little symbol, which a little looks like O, but a line through it. It's called a null set, which means the same thing, that there's nothing that we can find that makes this true. All right, kids, now your job is to go to the independent work, which looks like this. Okay, it says 4, 6 in the top, and you're going to do the 5 multiple choice, followed by the number 6, 7, and 8. You're going to write that on a single side of a paper, take one picture, upload it, and then you guys are done for today. See you guys tomorrow.